Alrighty, everybody. So we're about 5 minutes in. So that means I'm going to start answering your questions from the Google Classroom. Alrighty. If you had any questions submitted before this morning, I will be answering those now. I'm also going to be trying to track them so I can give you an idea of whose questions I answered when. Okay. So let's take a look at, well, I'm going to take a look at our Google Classrooms for any of our questions we might have had. I just need to raise up my screen a little bit. Alrighty. So looking for some more questions. So I've got a couple people who said they would like more practice with equations with acids and I need to, my screen's on a gimbal, so got to get it moved. With acids and metals, and I'll do that in a few minutes. But first, I'm going to hit some specific questions. Okay. Layla asked, how do you do number 9 on page 29 in the packet? I addressed that one in yesterday's extra help because a couple other people asked me about that as well, but I'm going to go ahead and do that now for you. Okay, so number 9, give me just a moment. All right, hopefully this will work for us. It was being touchy yesterday. All right, so number 9 looks like this. We've got strontium. Come on now. There we go. Plus acetic acid, which is also vinegar. Ooh, I'm not liking how that's looking. And what is it reacting with? Well, the thing to know is that this part of the acetic acid, this hydrogen, is the one that is going to come off and be replaced by the strontium. Got to remember, whenever we're reacting a metal with an acid, we're really just doing a single replacement reaction. Okay. Very, very straightforward. So let's take a look at what's going to happen here. So we're going to get our hydrogen gas. We always get our hydrogen gas. And then because the strontium is going to come in and replace this hydrogen, but the strontium is a metal, which means it's a cation, we have to write it first. I'm going to need my parentheses because this is a polyatomic ion and we are going to need 2 of them. So that is what number 9 on page 29 should look like in the end. And the reason why I needed 2 acetic acids is that my strontium had a charge of +2 and the acetic acid had a charge of -1. All right. And I don't show those in the final version, so let me get rid of that. Alrighty, so that is what our answer for number 9 on page 29 should look like. All right, let's look at some other questions. Alrighty, I'm going to come back with some more examples for acids and metals in just a minute. I'm going to just check our other class and see if we had any questions submitted between yesterday and today. Alrighty. So, Morgan asks if we can go over table J and table M. Okay, so I'm going to try to do that with you now. Give me just a moment. We're going to start with table J. So if you have your reference table out, go ahead and get that out. And here here we go. Okay, I apologize for the glare. Let me see if there's something I can do about that. Nope. Aha. Okay, so table J, we're looking at the activity series for different metals. And when we're looking at that, the thing to remember is that your most active metals are at the top, your least active metals are at the bottom. And when we're talking specifically about acids, it's this hydrogen down here at the bottom that we need to watch for. So if a metal will react with an acid, it has to be above that hydrogen. If it doesn't react with an acid, it will be below that hydrogen. It goes back to our rule about single replacement reactions. In order for the thing that is alone to replace the thing in the compound, it has to be higher than the thing that is bonded in the compound. So since we have a metal that's free state and we're wanting to react it with a hydrogen that is in an acid, it needs to be higher than the hydrogen. Alrighty. And she asked me to also take a look at table M. So let's take a look there. Give me just a moment to adjust my page. Okay. So table M has our indicators on it. The thing to remember about table M is that your indicator is listed on the left, the color shift is listed on the right, and where that color shift happens is listed in the middle. A lot of people think that these numbers mean that's the only thing that indicator measures, but that's really not the case at all. All this means, specifically, for example, for methyl orange, is that at 3.1, it starts to change from red to yellow. At 4.4, it's completely yellow. Between 3.1 and 4.4, it's orange. It's a shift from yellow to red, or sorry, red to yellow. Down here in phenolphthalein, I bring this one up because we discussed it quite a bit in our talk about titrations this week. In phenolphthalein, that shift from colorless to pink starts to happen at a pH of 8, finishes at a pH of 9, and by the time you're at 9, you're bright pink. Okay, so that is the way that table M works. Alrighty, let's take a look and see if we have any other questions that have been given out since yesterday. Okay, so Raina asked, when writing the salt part of the equation, which between the salt, metal, and acid, which to put forward first when writing them together. So the thing to remember is when you are writing any formula, your cation always comes first. So the positive ion always come before the negative ion. So when you're writing your salt, metal that came from the base is going to be the positive cation because metals almost always, well, virtually always have a positive charge when we're doing this kind of acid-base chemistry. Alrighty, let's take a look, see if we have any others. And forgive me, my system just froze. So Jenna asks, do Cu, Au, and Ag not react with acids at all or just slowly? For the most part, they don't react with most common acids. There are some acids you can use. There's something called aqua regia, which is a combination of nitric and hydrochloric acid. And with that specific combination, you actually can get it to react with some of the noble metals like silver and gold. But your common metals don't react, or if they do react, it's at such a slow rate that it's almost as if no reaction is happening at all. We can get into some more complicated acid metal chemistry, Jenna, if you want to. We can do a little chat on that. Alrighty, so that hits all the questions that have been asked in the classroom prior to this. And I had a request to do a couple more reactions of acids with metals questions. So I'm going to just throw a couple examples down on some paper and we'll work them out together. And then I will wait for questions from you. Alrighty. So let's say that we are reacting a metal, oops, like, gotta think of a good one. Gotta pull out my periodic table. It's one of those mornings. Let's see, what metal do I want to use? Okay, let's use nickel. So we're reacting nickel, and we're going to react it plus, let's use phosphoric acid. Let's do one that's a little more complex. Okay, so we're going to react nickel with phosphoric acid. The first thing that we know is that the phosphoric acid is this hydrogen is going to come off of the phosphoric acid and it's going to become a hydrogen gas. All right. You get that every time. No exceptions. Then we're going to be reacting our nickel with our phosphate. Now I cannot leave it like this because phosphate has a charge of +3 and nickel has a charge of, phosphate has a charge of -3, nickel has a charge of +2. That means that I'm going to need a subscript of a 2 here and a subscript of a 3 there. Now, here's where people get hung up. They look, they say, but I've got 3 hydrogens and I've got 2 hydrogens. What do I do with that? Well, you deal with that in your balancing. So the way that I am going to balance this, I am going to put, and I'm just going to switch colors for the balancing. We're going to put a 3 here. Nope. Hold on. Thank goodness for whiteout. Okay, we're going to put a 2 here and a 3 here. And now our hydrogens are balanced. This also gives us our 2 phosphates that we need on the product side. Now all I have to do is deal with this 3 nickels, and that's easy to do by just throwing a 3 in front of the nickel. All right, I'm going to do one more example for you. I'm going to pick another transition metal. I don't know why. Feeling the transition metals today, guys. Let's do, ooh, here's a good one. Let's do rubidium. Okay. No, don't want to do rubidium. Too easy. Let's use, okay, let's use manganese. Okay, manganese. In this case, I'm going to react that manganese with sulfuric acid. Okay, now we already know we're going to make hydrogen gas, so I'm just going to get that out of the way and go ahead and fill that in. Now, what else do we have? We have our metal and then our polyatomic ion here from our sulfuric acid. Okay, now this is nice because manganese has a +2 charge, sulfate has a -2 charge. I know that from either looking it up on the periodic table for manganese or looking it up on table E for sulfate. So they cancel each other out, so I need no subscripts. All I have to do to balance this is walk away from it because everything works out just fine. It's already balanced because the number of each atom of each element on each side between the reactants and the products are already balanced. Alrighty. So because I've already answered all the questions from classroom this morning, I'm going to hang here. And if you have any questions, feel free to ask. Alrighty, we're in our last 5 minutes. If you have any questions, please pop on and ask them now. Otherwise, we're going to shut down. Alrighty, guys. I want to thank you for joining in with us today. I will be posting this in an edited format up on our Google Classroom page. As usual, stay safe, stay healthy, stay connected. Bye.